All right, we're doing our first day of Trig Identities. The first thing I was going to do is, before I get into it, on worksheet 34, I've always drawn my students, oops, you know what I'm going to do? An identity bank. So if you want to put this on a piece of paper, you can. You don't have to, though. This bank has a motto. This is the identity bank. And it has a motto says, "We make even trades." Just like when you go into a bank with some money, you can get a different form of that money. So if you have your change saved up in a big jar, what do you usually do? Maybe go to the bank and try to trade it out for bills, right? Okay, especially your dads who hate their change in their pockets. So in this bank, I don't know why I'm putting a door on it, but we're going to go in and see what's in the bank and what we can trade things for. One thing that we've definitely learned is something about some reciprocal functions. When we first started the unit, we realized we already knew about the sine, the cosine, and the tangent, but then I added on some new ones. One was called the cotangent, and it was the reciprocal of the tangent, but you're just never going to do that. So I'm not even going to put that one down, because you're not going to trade a cotangent. Well, you might trade a cotangent for a 1 over the tangent. You probably won't do that too often, but you might. So let's think about some other ones. The cosecant. What would be something you might want to trade that for that you've thought about? The reciprocal function is the sine. So that'd be 1 over the sine theta. And I should be putting a theta on all these. Oops. And then we had the secant theta, which we would realize is the reciprocal of the cosine, 1 over the cosine theta. You might use any of these in a night today in our identity solving. There's something else we talked about, tangent and cotangent, that were really important. So what's another way to write the tangent? Careful. Sine over cosine, because it's y over x. Okay. And then with that in mind, we could quick write down the cotangent of theta. It would be cosine theta over sine theta. All right. Now I've got a new one, and I'm going to show you where it comes from. Hopefully you've gotten into your head that if theta was in quadrant 1 here, that we talked about cosine was your x value and sine was the y. And the radius in the unit circle was 1. What's something else you know in your life that we worked in mathematics and algebra and in geometry that could apply to this? Leg, hypotenuse. The Pythagorean theorem. So I'm going to write some Pythagorean identities next. Sine squared theta plus, or you could have these backwards, cosine squared theta equals the hypotenuse, right? 1. So right from here, I said, okay, cosine squared theta plus sine squared theta is 1. And it didn't matter which one I start with. Most often you'll see it like this in books. So I'm going to manipulate this and get us a couple more Pythagorean identities. What if I took this and divided the whole thing by the cosine of theta, cosine squared theta? You don't have to write this part. Just watch. We're going to put these new identities in a moment into our bank. I'm just showing you where they come from. I know it's kind of tight on the side there. What's cosine over cosine then? Cosine squared over cosine squared. 1. What's sine squared over cosine squared? Look over here. Tangent squared. Equals, what's 1 over cosine squared? Look over here. So that's squared, so this would be secant squared. So I just got a new one. Now, instead of dividing everything by cosine, I'm going to do it again. I'm just rewriting the identities. Cosine squared plus sine squared equals 1. And now I'm going to divide it all by sine squared. You don't have to write this. I'm just showing you where a couple of identities come from. Cosine over sine is cotangent, so this would be cotangent squared, theta. Sine over sine, 1. 1 over sine, can't. Oh, excuse me. 1 over sine, cosecant, not secant. Oopsie. There we go. Cosecant squared. Those are Pythagorean identities. You can always mess with this one as well. What if I wanted cosine alone? What would I do? You're not sure? How would you get cosine squared alone? Subtract the sine squared. So cosine squared is 1 minus sine squared. Could I get another one from that? Take this, instead of saying cosine squared, let's say sine squared. It would equal 1 minus cosine squared. You can play around with this stuff a lot. Okay, so all I'm pointing out is we're going to be using this one today. We're going to be using this today. We're going to be using all this now. So let's go to our worksheet. Oops, I don't want one that's already written on. I already have this one. So there was the identity bank. And here's our bank on your paper. This is on worksheet 34A. And then we're going to go to B as well. All right, so again, if you would like to take this, and you could actually write a couple more down if you wanted. Okay. Good enough. These are ones who are the basic trigonometric identities. We're going to play around with things now. Find the exact value of each expression. Find the tangent theta if you know the cotangent of theta. Okay, there's a couple ways to do this. But let's say I said you need to do this using Pythagorean identities. The cotangent of theta is cosine over sine. So I've got 4 over 1. So then the tangent of theta would be sine over cosine. I mean, this is one way to look at it using identities. There's actually a bunch of ways. So we're going to just flip it over and do 1 over 4. I could have said other ways as well, but what I need to read and identify up here is what quadrant are we in? If it says from 0, you got to know how to read these. This says that theta is between 0 and 90, so yes, Anthony, that is quadrant 1. So if we're in quadrant 1, they are all positive. Sine, cosine, tangent, cotangent, secant, and cosecant. All right, so the tangent of theta would be positive 1/4. I also want to remind you of some more things that we learned in this chapter. Cotangent was cosine over sine, and remember that that's x over y. So if you were in quadrant 1, remember that the x value would have been 4, the y value would have been 1, and then you could have thought of it this way, using your right triangle trig thoughts, opposite over adjacent, etc. Okay, with that in mind, I'm going to draw this one, and I'm going to use a Pythagorean identity. The cosecant is the reciprocal of the sine. We're in quadrant 1. If I'm given the cosine, this is x, and this is r. Remember x over r? I'm trying to refresh your memory of some things we did back at the beginning of the unit. So I'm going to draw it quadrant 1 again. X is the square root of 3 then. R is the long side 2 here. And then we wouldn't know what y is, and we could find it using that x squared plus y squared equals r squared. Remember that? Okay, that is very similar to cosine squared plus sine squared equals, in our unit circle, 1. Okay, so I got multiple ways I can do this. These are all related. So if I want to use this identity, I could just put in cosine is the square root of 3 over 2. So I'm going to try it using the identity. Square root of 3 over 2 squared plus sine squared theta equals 1. Anthony, do you have a question right now still? Okay. Okay. If you square this, you get 3/4. Squaring the square root of 3 is 3. Squaring 2 is 4. I could then subtract 3/4 from 1. What's 1 minus 3/4? 1/4. And then I'd take the square root, and guess what? If the sine squared theta is 1/4, if you take the square root of both sides, reminder, how many answers does a squared problem have? Okay, plus or minus 1/4 would be plus or minus 1/2. Square root of plus or minus 1/4 would be plus or minus 1/2, which is the answer. Well, it told us in the beginning we're in quadrant 1. It has to be positive, but we have the sine, not the cosine, or the cosecant, excuse me. All right, so if the sine of theta is 1/2, the cosecant of theta is 2. Now you might be saying, well, why are we doing it this way? Why can't we use our unit circle? Well, you can, if I don't specify what type of method you have to show it by. You also, though, are going to have things that aren't on your unit circle coming up in just a minute. All right, so it doesn't always have to be things that are on the unit circle that you can use these identities for. You can find lots of stuff using the identities that aren't on the unit circle. Okay, number 3. Oh, well, it's saying sine of theta is 3/5, find the cosine of theta. I'm going to use my Pythagorean identity. I'll also draw and remind us we are in quadrant 1. Sine is y over r. So y would be 3, r would be 5. And then I bet some of you already know, bang, what this is. 3 squared plus x squared equals 5 squared. That's going to be 25 minus 9 is 16. You're going to get plus or minus 4. So the cosine should be, adjacent over hypotenuse, it should be 4/5. We are in quadrant 1, so it would be positive. I want to continue on with showing it by an identity. It was cosine squared plus sine squared equals 1. That is the identity. I'll show you how we can get it from here as well. So cosine squared theta plus 9/25 I'm sorry, that shouldn't say plus 1. I don't know how I made a plus sign there. It should be equals. And then I'm going to have to subtract. So you could always type on your calculator 1 minus 9/25, and then hit math enter enter to get your 16/25. Okay. Just a reminder, this is what I was doing in my head. Okay, take the square root. We're going to get cosine theta would be plus or minus the square root of 16/25 equals plus or minus 4/5. And then we decided it had to be positive because we're in quadrant 1. All right, so whatever way we get it, that if I don't specify on your unit test or the next quiz, then get it whichever way you find more comfortable. But that's not on the unit circle, agreed? No 4/5, no 3/5, blah, blah, blah. All right, tan theta is 4/3 sine cosine theta. Okay, but I'm back to quadrant. I'm in quadrant 1. Tangent is y over x. So y is 4, x is 3. Cosine is x over r. So I'm going to need to find that hypotenuse there. Is it 5? Okay. Yeah, very similar, isn't it? Okay, so the cosine should be adjacent over hypotenuse should be 3/5. Good enough for that one, or do we want to go with an identity? Oh, I can show it with an identity. 1 plus tangent squared equals secant squared. 1 plus 16/9. If you do 1 plus 16/9, you get 25/9. And then you would take the square root. 5/3 equals the secant of theta, and then you could flip it and get the cosine of theta. Good? Sure. I will wait a moment. I want to get to the away from these number ones. There's some that aren't all just messing with numbers coming up. All right, find the exact value of each expression. Oh no, between 90 and 180. What quadrant are we in? All right, in quadrant 2, all students take calculus. Remember that way to remember what sign they are, positive or negative. Okay, all students sine and cosecant then are positive and the rest are negative. So if I'm finding the secant, it's going to be negative. You might want to note that right away. So then I say, okay, well the cosine of theta is negative 7/8. I want the secant, which is simply the reciprocal of that. Oh no, I'm not in quadrant 1 anymore. I think I'll draw that differently and remind you how to draw it. If I can get it drawn right. Okay, so this is x over r, so that's negative 7 for there and 8 for the hypotenuse. And you want the secant, well, that's simply the reciprocal of the cosine. The secant is r over x, and so it would be just negative 8/7. Get that one done quick. All right, and then let's keep going and find our cotangent. If our cosecant is 12/5 and we're in quadrant 2, cosecant is the reciprocal of the sine. So the sine of theta would have been 5/12. Since sine is y over r, then this is r over y. So that makes the hypotenuse 12 and the y value 5. We want to find the cotangent. Well, here's our reference angle. Bless you. I need to know this. So I might want to use 1 plus the cotangent squared theta is equal to the cosecant squared theta, that identity. Cotangent, I'm trying to find. Oopsie, I forgot to write squared on the cotangent. Cosecant squared would be 144 over 25. So go ahead and take your calculator if you need to and subtract 1 from 144/25. What's 144 minus 25? 119. Okay, that's 119, and this is 25. Now I have to take the square root. Cotangent of theta will be plus or minus the square root of 119 over 25. So I'm finally going to get my answer to this one. Cotangent of theta for this problem is going to be negative. Why? Cotangent is negative, isn't it? In quadrant 2. So it'd be negative square root of 119 over 5. You got the same thing doing Pythagorean theorem over here, because this would have been negative 119. Oh, sorry, negative square root of 119. $144 minus 25. That's a hypotenuse. I'd still have 144 minus 25. Yeah. Square root of 119. All right, finally, where are we now? 270 to 360. You need to know how to read these and identify your quadrant. That's quadrant 4. All students take calculus. Cosine and secant are positive. The rest are negative. Okay, so if cosine and secant are positive, then sine is going to be negative. Okay, so number 7's answer should be negative. Oh, and the cosine is 6/7. Find the sine. I'm going to use cosine squared plus sine squared. So 6/7 squared plus sine squared theta is 1. So sine squared theta is going to be 1 minus 36/49. Okay, what's that? 49 minus 36, is it 13? 49th. And then we're going to take the square root, and it's plus or minus the square root of 13 over 7. So negative square root of 13 over 7. I could have drawn it for you. Remembering that cosine is x over r. This would have been 6, this would have been 7, and then you would have found this to be negative square root of 13. Okay, let's just do 8 quickly because sine and cosecant are reciprocals, so sine's going to be negative 4/9. Okay, does anybody still need this page? All right, now to get to things a little bit different. We're not getting number answers here till the last question in the whole thing. So now I want to do the identity bank. What can I trade that with? No. Sine squared is 1 minus cosine squared. So I'm going to trade that for a sine squared theta. I am going to trade the secant for a, what can I trade secant for? Go to the bank. 1 over the cosine. And what can I trade the cotangent for? You're going to get this memorized. Tangent is sine over cosine. Cotangent is cosine over sine. I do not want to write 1 over tangent. I don't see that helping me in the problem at all. So what we're trying to do, and what my suggestion is, most of the time, you're going to trade these four things in terms of sines and cosines, if possible. 1 minus cosine squared, I want to start to recognize pretty quick, equals the sine squared. And then if I have this in terms of sine, I probably want to change those to terms of sine or cosine. Now, let's think of this as a fraction, of course. What's going to cancel out? Yes, Anthony. Oopsie. No, I just was bad and didn't write my thetas on those two. My mistake. I should have left them there. Theta, T-H-E-T-A. No. All right, and a sine cancels with this sign. So what do we have left? That's it. Okay, a little bit too much goofing back there. It's kind of getting to be a little old. Sorry. All right, simplify. When we're just doing a bunch of examples with you, this takes practice to get to know what to do. Sometimes you just want to start over if you're not getting anywhere. The cosecant, what do you think we should trade that for? Yes, 1 over the sine of theta. And I should be writing my thetas. I'm going to trade the tangent of theta for, okay, it's worth sine over cosine. Notice I said worth, kind of weird. It's because of the bank. I'm going to cancel out my sines. I am left with, you're technically replacing these, you cancel with ones. This is 1 over the cosine of theta, and then you would go ahead and write for me that that's equal to secant theta. Okay, next I have a sine squared and a tangent squared. If I already have a sine squared, I'm not going to change it. Okay, I'm just going to rewrite this as sine squared theta over, I'm going to trade the tangent for something. Tangent's equivalent to sine over cosine. So this will be sine squared over cosine squared, and let me explain why. The tangent squared, I say it like that because that's how you write it. It's really tan theta squared. This is really tan of theta quantity squared. But you put the 2 on there. That is how it's written. So that's why this is equivalent to this. Now, if sine squared theta is being divided by sine squared over cosine squared, we can rewrite this as multiply by the reciprocal of the fraction on the bottom, cosine squared theta over sine squared theta. All right, and then our sine squareds would cancel out, and all we have left is cosine squared. And that you would just write that is the simplified form, simplest form of that. What? Okay. Try another. Suggestions, please. And then do what? Change the cotangent, trade the you're trading it out for something equivalent. Yeah, you're not getting rid of it. Okay, you're trading it for something, and you must show these details. You have to show the steps. Oops. Okay, and now the cosine squareds cancel, and you get cosine squared theta. Did I say something wrong? I said cosine squareds. Oopsie. The sine squareds cancel, and you are ending up with cosine squared. Okay, I don't know. What about this one? Do we have a identity that says anything about the cotangent squared or something else? Isn't that an identity? It equals what? Yeah, that is one of our Pythagorean identities. Okay, someone make some suggestions. What could I, okay, so you want to trade something on the top? What does cosecant squared equal? Doesn't it equal 1 plus? Oh, let's just, okay. I see a cotangent and a cosecant. I know those are related as a Pythagorean. Let's trade the cosecant squared for a 1 plus, oops, isn't it 1 plus cotangent squared? All right, minus cotangent squared theta. That's what we'd have on top. So here, I traded this for 1 plus cotangent squared theta. You with me? Because then I'm going to take away, and that's going to be helpful. On the bottom, I'm going to trade this for a sine squared. Okay, now I just wrote that because I'm trying to help you learn in my notes. This is what your steps should show. Now you would show that, well, the top simplifies to the cotangents canceling out, so you're going to have 1 over the sine squared. And then finally, you'll tell me that that equals, yeah, so cosecant theta squared. Now, I don't care if you write it in, like, memory. Cosecant squared theta. Well, we're looking a little bit messier on 16. 14. I can't cancel these out. I don't see any squared things. So since nothing here is squared, I'm not going to be using the Pythagoreans. So we got to go to sines and cosines. So let's, yeah, what are we going to trade the tan for? All right, sine over cosine. We're going to trade the cosecant for 1 over the sine. And then we're going to trade the secant for 1 over the cosine. Oh boy, that looks worse. Let's do something in the numerator first, though. Okay. Don't I have 1 over the cosine? Oh, 1 over the cosine on the top, and I'm going to multiply by the reciprocal of this. Cosine over 1, and we end up with 1. Okay. I see a sine squared theta. It's starting to get a little more complicated, okay? It's going to take a little longer to get there on this. I see these cotangent and tangent. I'm going to trade them out. Let's get it all sines and cosines. So I'm going to rewrite sine squared theta minus, and then I'm going to do tangent is cosine over sine. Tangent is sine over cosine. And on the bottom, cotangent is cosine over sine times the sine. Okay, let's see what we got. So if I multiply the cotangent and the tangent, and they're reciprocals of one another, what should I actually get right here? Yeah, 1. So I've got sine squared theta minus 1 on top. And then what happens here? The sines cancel, right? And all I have left is cosine. Gotta go again. What can I trade this for? Cosine squared. So I've got cosine squared theta over cosine theta, which reduces, yes, to cosine. The final answer is cosine theta. From here. Because sine squared theta plus cosine squared theta equals 1 gives me 1 minus sine squared is cosine squared. Sorry. That identity gives me this or the other way around. Yeah. All right. Last one. Well, there's 2 more, right? What do you think? Can't really do anything with the top. But what can I do on the bottom? Trade secant for a 1 over cosine. Trade tangent for sine over cosine. Now, what's nice about that is they have the same denominator here. So I can write the numerator over. This would be 1 minus sine theta over cosine theta. And now I would want to multiply by the reciprocal of this. And we still have a little ways to go. Cosine times cosine is, yep, cosine squared. So I'm going to come down here to continue the problem. Cosine squared theta over 1 minus sine theta. Okay, now, Okay, cosine squared equals 1 minus sine squared. Now it's starting to look like something could happen. But I can't, they're not even. Like, I can't cancel that out and what would I leave, you know? No, you do that. So, you see this? Think about this for a minute. How do you factor that? Wait, I'll make it like that. How do you factor that? Can I factor this? 1 minus sine squared is 1 minus sine times 1 plus sine. That's kind of nifty. All right. So yes, you are going to have to start thinking like that a little bit. It's a difference of squares. So I can get rid of that 1 minus sine and the 1 minus sine. And there's my final answer to that one. It is 1 plus sine theta. Okay, your assignment is on worksheet 14, but I have one last example. Okay, here, this is kind of neat. You'll be surprised what's going to happen. No. I'm just going to rewrite these. The products, remember you can do 3 times, this would be sine over cosine. Cotangent is cosine over sine. What do you get here? Isn't this just 3? Sine and cosecant. Sine theta times 1 over sine theta. They're reciprocals. What do you get when you multiply reciprocals? 1. So this is 1 plus 4. And over here, cosine theta times 1 over cosine theta is 1 again. Oopsie. I can write. Tired. All right, so we get 1 again, and this would be 3 plus 4 plus 2. Anthony! 3 plus 4 plus 2 isn't 8, it's 9. Just teasing. He went too fast. Thank you. Your assignment again. Worksheet 35. Oh, wait, 30. What number is it? 34? No, this was 34. Assignment's 35 AB. Practice. We're going to be doing more identities tomorrow.